So far in this course, we have spent most of our time talking about conservation and protected areas in terrestrial environments. In this video, we will shift our focus to the marine environment. We will discuss what marine protected areas are, their key features, and the global context of marine protected areas. We will take a deeper look at the Canadian context of marine protected areas in a later video. A marine protected area, or MPA, is simply a protected area in the marine realm. They have the same definition of a protected area that we saw in the last video and are held to similar standards. The IUCN has developed a set of global standards to guide ocean protection and what constitutes a marine protected area. Above all, they state that conservation has to come first, that it needs to be the primary purpose of an MPA. The goals, objectives, location, size, and design of the MPA must all be thought out with conservation in mind, and industrial activities such as industrial-scale fishing, seabed mining, and oil and gas extraction should be prohibited within the borders of an MPA. They caution that calling any form of marine protection, even if it does not meet these standards, a marine protected area, is setting ourselves up for failure, as it will create meaningless labels and only the illusion of protection, where in fact there is none or very little. They also stress that MPAs need to be adequately resourced. Managers need the staff, financial, and technological capacity to adequately meet their objectives. Similarly, there needs to be sufficient investment in compliance to ensure that MPAs are effective. Marine protected areas were added to the Convention on Biological Diversity with the 2010 Aichi targets, which set the goal of at least 10% protection of the ocean by 2020, and the post-2020 targets call for this to increase to 30% protection by 2030. Since the Aichi targets were agreed upon, the area worldwide covered by MPAs has proliferated, and currently about 7.5% of the ocean is protected in MPAs, which are shown here on the map. But it is important to note that the global conservation community has raised concerns that not all of these MPAs are being effectively managed, and that they are not all actively working towards ocean biodiversity conservation goals, and that some of them may even be working against conservation objectives. One metric that is often used to assess how well a conservation system is working to achieve biodiversity conservation goals is to look at how well species of concern, or even total biodiversity, is represented within the system. In our supplemental readings this week, there are a couple of papers that assess how well the global marine protected areas system represents biodiversity, one led by Clarissa Klein from the University of Queensland, and one led by Tammy Davies from BirdLife International. The one led by Dr. Klein assessed the overlap between the global MPA network and the ranges of over 17,000 species. Dr. Davies and her colleagues conducted a similar analysis, but focused solely on the largest MPAs, just those that are larger than 30,000 square kilometers, and they also looked at not only how well these areas represent marine biodiversity now, but they also considered how effective they would be under climate change. Both studies indicated that while almost all of the species examined had at least some of their range covered by a marine protected area, very few had more than 10% of their range protected, leading both papers to conclude that representation is not being adequately achieved in the current global MPA system. These concerns over the state of representation in the global MPA system led Dr. Davies and her co-authors to make 5 key recommendations. First, they argue that it is critical to increase protection for those species which are currently underrepresented. This is a bit of a no-brainer, as in order to be effective, we know that protected area systems need to be representative of the species they are aiming to conserve. But they also make the point that it is important to not only consider the current distribution of species, but also their projected future distributions under climate change. Third, they call for more of a focus on those species with varying distributions, as those species that are highly mobile or migratory need protection throughout their entire range and life cycle. For example, many sea turtles take on long and complex migrations between the waters where they live most of their life and the beaches where they breed. Different parts of this migration will expose the turtles to different stressors, from predators and adverse weather to human impacts like habitat destruction, fishing mortality, and ship strikes. While a lot of attention is often placed on the conservation of nesting beaches and key foraging areas, at least during the times of the year where the turtles are present, There also needs to be consideration of the corridors used to connect these key areas. Some scientists have also advocated for movable marine protected areas based on where key species of concern are at any given time. We will look more at this approach in the next video. Fourth, they highlight the need to explicitly consider threats in the priority setting process. Just like we talked about in the terrestrial environment, the protection of relatively undisturbed marine wilderness is important, but so too are more vulnerable and altered seascapes. Measures can and should be taken to reduce the threats to species in more vulnerable areas. Building on this, they note that it is time to move away from opportunistic MPA establishment to a more systematic identification of MPAs. In other words, the principles of systematic conservation planning, which we looked at earlier in the semester, should be applied to the marine environment. Adding to these recommendations, Dr. Klein and her co-authors noted that over 99% of the poorly represented species are found within exclusive economic zones rather than in international waters, suggesting that while international collaboration is important, there is a lot that individual countries can do to improve conditions for marine biodiversity, but that it may require making tough choices in balancing conservation and economic interests in the ocean. Representation is of course important in marine protected areas, just as it is with all protected areas, but it is only one piece of the puzzle. Think about all of the other elements of a successful conservation network that we have been talking about in this course. Things like redundancy, resiliency, connectivity, and enforcement. All of these are also important in marine protected areas. In response to these concerns, a study led by Graham Edgar from the University of Tasmania investigated the conservation benefits of 87 marine protected areas from around the world. The paper, which is available in the supplemental readings this week, looked at the cumulative effect of 5 key planning and management features: the degree of fishing permitted, the level of enforcement, the age of the MPA, the size of the MPA, and the presence of continuous habitat, allowing for the unconstrained movement of fish across MPA boundaries. They surveyed the total biomass and species richness of fish in each MPA, as well as estimated the total biomass of 3 commercially important taxa: sharks, groupers, and jacks. Overall, they found that the area of MPAs alone will not optimize the protection of marine biodiversity, and they argue that more of an emphasis is needed on better MPA design, durable management, and compliance. They determined that the key features of a successful MPA are that they are no-take, that they are enforced, old, large, and isolated, what they call the Neoli factors. In other words, for an MPA to meet its conservation goals, it needs to prohibit fishing, specifically industrial-scale fishing, and this ban on fishing and other industrial activities needs to be enforced. The MPA cannot simply be a paper park, existing in legislation but not in the real world. They also need to be of sufficient size to support species and processes of concern, and they need to be of sufficient age to have allowed for the ocean to have healed from past exploitations. They suggested that at least 10 years need to have passed between the first regulations on fishing restrictions and the present for a noticeable recovery to have started to occur. They also found that the most successful MPAs are those that are isolated from industrial fished habitats. They also found that there were no significant differences between fish sites and MPAs with only 1 or 2 of these Neoli features. However, they found that the effects of an MPA rose rapidly when the number of features increased from 3 to 5. They also found that the first 4 features, no-take, enforced, old, and large, seemed to contribute a similar increase in fish biomass within MPAs, but that isolation seemed to exert a stronger influence for fish biomass and species richness metrics than the others. Looking around the world, only a small subset of MPAs are ever going to meet all 5 Neoli conditions, especially the size aspect. But most could achieve the others, which, as previously mentioned, would do a lot for boosting ocean conservation. It is also important to note that the establishment of effective MPAs will not happen overnight. MPAs require the time to age in order to allow fish populations to rebound, and there needs to be sufficient will to make the MPA successful. There needs to be sufficient buy-in from all stakeholders, including the fishing industry, politicians, and enforcement agencies, to implement effective no-fishing zones and work towards ocean conservation.